This video covers the third of 4 methods of solving quadratic equations that we go over in Pre-Calc 11. Before this video, I've already gone through solving by graphing and solving by factoring. And in this particular video, I'm going to go over how to solve by completing the square. So doing all of this stuff relies on skills that you should hopefully already have. If you're completing the square is a little bit rusty or you haven't learned that yet, make sure you go back and look at the Chapter 3 videos for this course that teach you how to complete the square. Once you're fresh on that, come back and we'll go through how to solve using it. So let's say we wanted to solve something that looked like x squared plus 10x plus 21 equals 0. So pretty standard looking quadratic. We could solve this by factoring. It's what multiplies 21 adds to 10. It'd be 3 and 7, and this one would actually be pretty easy to do. But there will be a lot of cases where things aren't factorable, and so completing the square will be necessary. So if we want to solve by completing the square, the first step, probably not super surprisingly, is to complete the square. So we want to get this thing into vertex form. So I'm not going to spend a bunch of time in this video dwelling on the process of completing the square, so do make sure, like I said, that you go back and double check previous videos if you feel like you need it. But I'll do one quickly. So x squared plus 10x plus 21 equals 0. So remember, we got to put brackets around the first two terms. We're going to take the 10, our coefficient on our x, and we're going to divide it by 2 to get 5, and we're going to square that to get 25. And then we're going to take 25, and we're going to add it and subtract it inside the brackets. And then we're going to move that negative 25 out of the brackets to get to something that looks like this. And then we're going to factor the brackets, and we're going to simplify that stuff on the outside, and that'll get us into vertex form. So we get x plus 5 squared minus 4 equals 0. So remember when we were solving by graphing, we would have now graphed this. The downside to solving by graphing is that you have to graph, and it's time consuming, and we don't always have graphs. And it also wasn't super precise if the answers weren't super clean. But let's keep some of the processes of that in mind. So if we drew a really quick sketch of this, our vertex at -5, -4 would be somewhere down here. And since our a value is positive, our graph opens up. So we know from looking at that we're going to have two solutions. So we're going to have to keep that in mind because that's going to come back to us later. Now that it's in vertex form, we've completed the square. Now we want to actually start solving. And the way we're going to solve this is actually using skills you have had since probably grade 6, grade 7, grade 8, solving equations. But we're specifically solving equations using opposite operations. So we're going to take that x that we've got in our equation and we're going to isolate it. The reason we haven't been able to do this up to this point is because most of our quadratics have had two variables in them, right? We've had, or rather two terms with variables. So we've had x squared plus 10x plus 21, things like that, where we've got x coming up twice. And so you can't really isolate something if there's two of them. But through the process of completing the square, we've gotten it down to just one single x in our equation at this point, which means we can isolate that variable. So, quick refresher before we do that. Remember, when you're solving, you're not going to follow BEDMAS because you're not doing operations, you're undoing them. So to undo operations, we're going to go opposite of BEDMAS, which is SAMDEB. We're going backwards. So follow SAMDEB when solving, but only when solving. So let's look at our equation. We've got x plus 5 squared minus 4 equals 0. So the first thing we've got is subtraction, and we do have a subtraction to deal with. So to get rid of that minus 4, we are going to add 4 on both sides. This should feel pretty familiar to you, which is going to leave us with x plus 5 squared equals 4. Then at this point, we don't have any multiplication or division. We do have an addition, but that addition is inside the brackets, so we can't deal with it just yet. But we do have an exponent. We've got this square here. So thinking back to probably Pythagorean theorem in grade 8, remember to get rid of a square, we're going to use a square root. So we're going to square root both sides of this equation. And that is going to get us x plus 5 on the left and it's going to get us 2 on the right. Leave yourself a little bit of space in front of this 2 because we're going to come back and talk about this in a second. So we've got x plus 2, or x plus 5 equals 2. And so to solve this, well, at this point we just need to move the 5. So we're going to subtract 5 on both sides, which gets me x equals 2 minus 5, which is just 3. Or sorry, negative 3. And so that seems pretty easy. But remember what I was saying earlier, we should have 2 solutions, right? But it seems like we only ended up with 1. And so the reason for that is something that you've kind of ignored up to this point in your math career, something that we just kind of pretended doesn't exist. So let's stop and think about a different situation for a second. Hop off to the side here. If I've got x squared equals 4, and I want to solve this, I would square root both sides, right? So square root on the left, square root on the right, and we'd get x equals 2. Makes sense, right? 2 squared is 4. But there is a different thing that when squared also would give you 4. And that thing is negative 2, right? Negative 2 times negative 2 is positive 4. So there are 2 valid solutions to this little equation here. And this is how we're going to get our second solution for every situation when we're doing completing the square. If there are 2 solutions, it's going to come down to this thing here. So when you square root both sides of an equation, like we did here, when we square rooted to get rid of that exponent, we had to consider both a positive and a negative option. So let's add that in down here. So when you bring in the square root, if the square root's already there, right, if you have, say, the square root of 9, that is just 3, because you know it's positive. But when we bring in the square root, when we create the square root, we don't know if it's going to be positive or negative. And so we have to consider both options to make our equation work properly. So when you bring the square root into the equation, you need to consider both the positive root and the negative root. And that's a really easy place to mess up because it's not something that you can see, it's something that you have to bring in yourself. So you really got to keep track of that as you're working. So positive root and negative root. Great. So let's swing back over here then. And in that space that I told you to leave in front of the 2 in this step, we are now going to add in this little symbol. So that's a plus with a minus above it, and that just means plus or minus. So it tells us it could be a positive 2 or it could be a negative 2. And so what we actually do here is we're going to split into 2 separate solutions. So I've already done one of them using the positive 2, but now we're going to do the same thing with the negative 2. So instead of x equals 2 minus 5, it's going to be x equals negative 2 minus 5. And that gets us our second solution of negative 7. And so that is basically the process of solving by completing the square. It's going to work essentially the same way. Right? We're going to do the same steps. It's just going to be maybe slightly harder solving or slightly harder completing the square. So let's try out another one. So we're going to solve x squared plus 6x plus 3 equals 0. And so immediately this one looks like it's not quite as factorable, right? Finding something that multiplies to 3 and adds to 6 doesn't seem like something we're going to be able to do easily, which is why we do want this completing the square method. All right, so step 1, complete the square. So again, this is something that you're going to have to get comfortable doing on your own. So remember, you divide by 2, you square, you add and subtract. Right? These are all steps you should be pretty comfortable with at this point. It's really the solving that is the key of this. So we end up with, once we're done, x plus 3 squared minus 6 equals 0. So that's completing the square. Step 2, we're going to isolate as best as we can. So we're going to do whatever we can to get that x on its own. So we got x plus 3 squared minus 6 equals 0. So same steps as last time. We're going to start by adding 6 on both sides, which is going to get me x plus 3 squared equals 6. Now we want to get rid of the root, but things are going to be a little different here. So when you square root both sides, on the left, that's just going to cancel out with the exponent, and that's totally fine. We get x plus 3. It's great. On the right, though, we get root 6, and that's not a clean root we can do. So You could turn this into a decimal here, but ideally we don't want to do that. We actually want to leave this as a root 6 for now, for two reasons. One, it's just annoying to have to deal with decimals more than you need to. And two, if we don't turn this into a decimal, if we leave it as a root, we can give a more precise answer later on down the line. So we're going to leave it here. So our next step to isolate our variable is to move that 3, but you'll notice, hopefully, that I forgot something here. So I told you it was easy to forget this. It's the plus or minus. So remember, when you do that root, when you bring that in, you've got to remember to do your plus minus. All right, so we're going to move the 3 to the other side. And that's going to get me x equals -3 plus or minus the square root of 6. Which is great. So our last step here is to split this into two solutions using that plus minus. So we're going to have one with a positive root 6 and one with a negative root 6. So our two solutions are x equals -3 plus the square root of 6, and x equals -3 minus the square root of 6. And so written as they are right now, these solutions are very precise because we haven't done any rounding yet, we haven't brought in any decimals. So these solutions are what we would call exact values. Right? We know exactly what they're supposed to be. Versus if you turn it into a decimal, I don't know exactly where that decimal came from. I don't know exactly how you rounded it, so it's not as precise. So this is one of the strengths of completing the squares. It gives us that exact value versus, say, graphing where we had to estimate, or factoring where we just wouldn't have been able to answer this one at all. We do sometimes want decimals, though, so if you plug these into your calculator, you'll get your approximate answers of x equals -0.55 and x equals -5.45. All right. So let's try it with an a value out front. So if we wanted to solve, say, 6x squared plus 24x minus 36 equals 0, how does that a value change things? We know it changes with completing the square, but how does it affect the solving? So let's find out. So quick refresher, if you're going to solve, or if you're going to complete the square with that a value, the first thing you need to do is take it out. So we've got our brackets on our first few terms, and we've got to take out the 6, which leaves us with x squared plus 4x, and then minus 36. We do the same stuff. We divide by 2, we square, we add and subtract, which gets me here. And then we still want to move that -4 out of the bracket, but when we do, we have to take the 6 and the -4, and we have to multiply them together. And if you don't remember why, go back and check the previous videos. So that leaves me with 6 times x squared plus 4x plus 4, and then minus 36 and minus 24, and that equals to 0. And so now we've got 6 times x plus 2 squared minus 60 equals 0. Right, so it's in vertex form. This is what we wanted. Now it's time to start solving. So remember, we're going to follow SAMDEB, and we've got to keep close track of what goes where, because we've got that a value now, and that is something that tends to cause people some troubles. So our first step is still going to be subtraction or addition, so we still want to start by moving the 60. So we've got 6 times x plus 2 squared equals 60. Great. But this is where things are a little bit different, because our next thing that we want to deal with is multiplication. So before we do the square root, we need to get rid of that 6, and that is something people tend to forget. So we, at this stage, want to divide both sides by 6, which gets me x plus 2 squared equals 10. And from this point on, this is just the same thing as the previous ones. We square root both sides, so we get x plus 2 equals plus or minus root 10. We move the 2 to the other side by subtracting, so we've got x equals -2 plus or minus root 10, and we're ready to get some answers. So we've got x is -2 plus root 10, which if you calculate it is 1.16, and we've got x is -2 minus root 10, which if you calculate it is -5.16. And so that's all the a value does, right? In terms of the solving, it just means you have to divide. It's just one extra step, but it's not a huge change. So those are most of the cases you're going to run into when it comes to solving by completing the square. Next few examples are going to dig into some more specific things that you are going to see from time to time, just to kind of make sure you're aware of what's coming. So let's say we wanted to solve x squared plus 8x plus 16 equals 0. So you're going to go through your process of completing the square again. So we put some brackets up. We divide by 2 and square. So 8 divided by 2 is 16. And 8 divided by 2 is 4, and 4 squared is 16. So we get x squared plus 8x plus 16 minus 16. And then we still have that plus 16 outside of the brackets. We move the negative 16 out. But when we do, it cancels out with the 16 that's already out there. So we end up with x squared plus 8x plus 16. And then those two have just canceled out. So we've just got equals 0. So this leaves us with x plus 4 squared equals 0. And so if you start solving this, we're going to square root both sides, which just gets me x plus 4 on the left, and on the right, that gets me 0. And so technically it's plus or minus 0, but plus 0 or minus 0 doesn't really make a difference, right? So if we move that 4 to the other side, what we end up with is x is just negative 4. And in this case, this is actually supposed to just be one solution. So our vertex, if you come back to the x plus 4 squared equals 0 that we had earlier, our vertex is on the x-axis. It looks something like that. And so you hopefully remember from the graphing lessons that if your vertex is on the axis, that does just lead you to one solution. So this is how, when you're completing the square, you end up with one solution. It's if you get a 0 inside of the square root. And so you might be wondering, well, how do I get no solutions? So let's take a look at that. So if I've got x minus 2 squared plus 1 equals 0. So it's already in vertex form. We don't even have to complete the square. So if we start by moving that 1 to the other side, like we should, we're going to subtract 1 on both sides. We get x minus 2 squared equals negative 1. All right, well, now it's time to square root both sides. And so we've got x minus 2 equals the square root of negative 1. But that is a problem, because you hopefully know from previous learning that you can't square root a negative. That's not a thing we can do. There's ways to make it work in upper level calculus and stuff, but for pre-calculus 11 in high school, this is just not something we can handle. We can't square root a negative, and so this equation has no solutions. And so that's going to be kind of the case in general. If the thing inside your root is negative, you get no solutions. If the thing inside your root is 0, you get one solution. And if it's any positive number, you're going to get two solutions. All right, let's wrap this up by looking at maybe some sort of application question. So we've got a golfer, and that golfer is going to hit a ball that's going to follow a specific quadratic path. So our path for our golf ball is going to be h of d, right? H is height, d is distance, equals negative 0.025 times d minus 20 squared plus 10. Okay. So great, this is a function, relates height and distance as this thing travels through there. And we should probably say with height and distance in meters. So a pretty typical thing that you would be asked would be something along the lines of, okay, well, how far does this thing travel before it lands on the ground? And so the key thing to consider about that is, well, when something is on the ground, how high is it? Because the whole function is about height. The distance is what we want to find, right? D is what we want. But what's the height? So if something is hitting the ground, if it's on the ground, its height is 0. And that is a really common thing to run into in quadratic word problems, is stuff being on the ground, or it might be specific height. So I might tell you how far will it be before it's 2 meters in the air or something along the lines of that. But the process is basically the same, where we're going to be given a height and we have to plug it in. And so we go to our equation. We're going to plug 0 in for h of d. And so we've got 0 equals negative 0.025 d minus 20 squared plus 10. And this is great because it's already in vertex form. So go ahead and try to solve this one for yourself. So go through all of your opposite operation steps, get this thing isolated, get yourself an answer, and then come back and see how you did. All right, so to solve this, I'm going to subtract 10 on both sides of my equation, which is going to get me negative 10 equals negative 0.025 times d minus 20 squared. Don't assume that just because you see a negative on the left right now that this thing's going to have no solutions, because when we do our next step and divide both sides by that negative 0.025, our negatives are going to cancel out, and so this will end up having two solutions. So don't start making assumptions until you get to the stage where you're doing your root. So when we do that division on the left, we're going to get 400. On the right, we're just going to be left with d minus 20 squared. So we're going to square root both sides, and we're going to get 20 on the left, but specifically remember plus or minus 20, and then we're going to get d minus 20 on the right. We're going to add 20 on both sides, and so we get d, our distance, is 20 plus or minus 20. And so if we split that up into two, our options basically become 20 plus 20, which is 40 meters, or 20 minus 20, which is 0 meters. We can probably be generous to our golfer and assume that their ball didn't travel 0 meters, and most likely 0 is where it started, right? So it's gone no distance when it's first on the ground, because it's on the ground when the golfer hits it, and then it flies through the air and lands 40 meters away. So our answer is the ball traveled 40 meters. You will have to interpret your intercepts, your solutions when you do these things. Sometimes you're going to want the difference between them. Sometimes you're just going to want one specific answer. Sometimes you might even need to add them together. So keep track of what the question's asking you for and make sure you're actually answering it. And there we go. So this is how we solve equations by completing the square. It has its pros and it has some cons. It's great in that it answers every question. It doesn't matter whether the solutions are going to be weird decimals. It doesn't matter whether the equation has decimals like this one that we just answered here, right? Because solving this one by factoring would not have been fun. It works for everything. The downside being that it is a little bit more time consuming than, say, something like factoring, where if we had gone back to this first one that we did way at the beginning of the video, we could have solved this by factoring in 2 steps. We could have factored it and then solved it in about 5 seconds. So it does take a little bit longer. It's not my go-to, but if you already have something in vertex form, or if you have something where the numbers just are not going to be fun, it is a really great strategy. In the next videos, I'm going to go over our final method of solving, which is the quadratic formula. So once you've really got this method nailed down, go ahead and take a look at those.